Example 1 for quadratic functions and graphing. So f of x equals negative 4x squared minus 2x plus 42. So on this particular function, we were given general form. We already talked about in the notes before. If you haven't seen that video, you'll want to take a look at that, or at least read through those notes. We know that our form is f of x equals ax squared minus bx plus c. So based on the notes that we were given, we know that when it's in this form, we can find the y-intercept really pretty easily by plugging 0 in, and we would end up with just whatever c is. So our y-intercept for this particular problem, we would do f of 0. We can just kind of do that in our heads, and we're going to get 42. We could write 0, 42 as a point. Or we could use the function notation I have on the left. Find the vertex of the graph. So because it is in general form, it's pretty easy to just use the axis of symmetry is our probably most simplified method. So we would have the x part would be minus b over 2a, and we proved that out in the notes page in notes video. So I'm going to plug in the values. So I would get x equals negative, and then my b is actually negative 2. So b equals negative 2. C is 42, A is negative 4. So I get negative and then negative 2 all over 2 times negative 4. So I end up with 2 over negative 8, which gives me negative 1/4 when I just reduce everything down. And then that just gives me my x value. So now I need to figure out f of x. So I'm going to want to do f of negative b over 2a, which is f of negative 1/4. So I'm just taking that 1/4 and putting it in to my function. So in order to do that, I would write it up as negative 4 times parentheses negative 1/4 squared minus 2 times negative 1/4. So I'm just plugging this value in for x everywhere, and I'm going to crunch the numbers. So this one does terminate, so you could make it be decimals, but I want you to try to work with fractions more and more and get used to that before you get to pre-calc. So we would have negative 4 times negative 1/4 squared is going to give us a positive 1/16. And then I have minus 2 times minus 1/4 will give us a positive 2/4. I'm going to reduce that later. And then plus the 42. So now I can go in and simplify things. So the negative 4 and the 16 will give me a 1/4 there. So now that's why I didn't change my denominator on the 2/4 right away. But I have a negative 1/4 plus 2/4. Okay, it's going to give me negative 1/4, or positive 1/4, sorry, positive 1/4 plus my 42. So that just equals 42 1/4. or I could go 42 times 4 plus 1. I get 169 over 4. So either format that you want to use is fine. What you should do in your final answer, though, is clearly write vertex and then write it as a point, -1/4, 169 over 4. I'm going to leave it as the improper fraction because that's pretty common use, unless it's a word problem. So that's our answer for that one. Then we're going to go on to C, write f in factored form. What are the x-intercepts of the graph? So this one is factorable. We don't need the quadratic formula. We could use it if, or another technique if it weren't readily factorable, but it is. So it's good review for you because that's, of course, going to be on your final and you've had that skill down. So if you can work on that, do this as a try it on your own. Okay, you're going to just factor the function that's above there. So pause the video. So I wrote a couple of the steps out. Well, I rewrote the problem. So when we push it up, we can see. And then f of x equals -2 times quantity 2x squared plus x minus 21 in parentheses. So what I did was just pull out the greatest common factor. So don't forget to check for that. You can't always do it. I do notice sometimes when I'm grading that I see people trying to pull out a common factor, but it has to be common to all three things. The only time that we pull out pieces is sometimes when we're transforming, but we're careful when we do that. There's a certain technique. And also for completing the square, if we have a coefficient, we have to factor out just of the first two terms, but we account for that later. So that's not what we're doing here. When we have this general form, we want to pull out a greatest common factor of all three terms. That's the technique we're using for this specific problem. And all trinomials like that, unless we're doing completing the square or doing some kind of vertex form, something like that. So now we're going to have to factor what's left in there. So f of x equals -2 times, and I'm going to make my binomial. Again, brush up if this is not that familiar to you. So I would have a 2x and an x are really my only choices. The 21, 7 and 3 ring, like they'll work for me. So I'm just going to try anything I could try. Let me try doing -7 and a +3 and see how that goes. Well, I would get, right here, I would get a positive 6x and a -7x, which would give me a -x. So I know that can't work because I would have my sign off. So I'm just going to switch the signs. And if I happen to reverse that, like say I put the 7 over here, I know that would be pretty big. That would be a pretty big difference. So that's why I wouldn't want to put the 7 where the 3 is, because I would get too big a number to work with. So those are my factors, and then set each factor equal to 0. So the -2, or set the whole equation equal to 0 actually. 0 equals -2 times 2x plus 7 quantity x minus 3. And this -2 actually will just divide out and leave us with 0 equals 2x plus 7 times quantity x minus 3. And then set each factor equal to 0, and I would get x equal to -7/2, or x equal to 3. And if I had a word problem, I might have to say one is extraneous because it doesn't make sense to the domain of the problem or something like that. But this one is just a, kind of a generic. So when I'm graphing, I might want to put things in mixed numbers or decimals, but when I write it out, I will want to leave it as an improper fraction. So I'm going to have X-intercepts, parentheses, -7, 2, 0, because I'm going to write them as points, and then parentheses 3, 0. So that's my answer for the X-intercepts. Up here I should label that's my Y-intercept for part A. And now I'm going to sketch a graph. So I can use all this information to sketch my graph. And I have to set my scale to something that'll work well. So let me just put the axes in there. Make sure you put the axes where they make sense to go. I'm just going to put mine in the middle. I don't have a straight edge on this app, so just forgive that, but you should try to use one. Anything will work. It doesn't have to be a ruler. So on this, I'm just going to set my horizontal axis to be units of ones. That'll be a 5, 2, 3, 4, 5 left, and a -5. And then the y-axis, I'm going to use tens. 10, 20, 30, 40, 50 up here. And the reason I'm doing that is because I know that my y-intercept was 42. So that's going to be a little hard to plot if I have them too tight, but also I want to be able to not go off the graph too much. So this was 40, so 42 is right about there where I'm putting that pink dot. My vertex was 42 1/4, and that's where if I have it as improper, I might want to make it a mixed number just to know how that's going to sit. So it's just a tiny bit, and then -1/4, so it's just a tiny bit to the left and up of that. And then my intercepts, I had -7 halves, which is 3.5. And then I have my right side is 3, 0. And then I'm going to go ahead and make my parabola. It's not too good looking. Try again. Again, these don't have to be perfect. You don't want it to be a V though, and you want to try to have it symmetrical. Okay, so there's my beautiful graph. The points, we would want to label them as our vertex would be the -1/4, 169/4. Our y-intercept is 0.42. Our x-intercept over here is 3, 0, and then our left side is -7 halves, 0. It's opening down, which I would know from my A value, it being negative. I know that it's going to be not super wide, but not real skinny because 4 is kind of a low number. And it behaves as the global behavior, which is something that you'll learn about later, but your domain, X, will approach let's see, that domain goes to positive infinity. As this one, that's a little bit, but it's gonna always continue out forever. So X will approach positive infinity as my Y, but the Y is going toward negative infinity. As Y goes towards negative infinity. And then on the left-hand side, X is approaching negative infinity, going, off this way. The doesn't look like, it looks like almost it'll go straight down, but it's not. It's going to negative infinity as y approaches negative infinity. Let me talk about that in pre-calc, Math 141. So Desmos is a great tool. You can check your graphs. You should know how to do them by hand as well, just because that's good practice. But you can use Desmos and bring your laptops to class and stuff for the hybrid. For online, if you have questions, I can try to help you virtually. So have a great day. There will be a couple more examples using the different types, so we'll go through those as well. So make sure you check those out.